What do radio waves, microwaves, ultraviolet, visible light, and X-rays all have in common? Find out today on Quantum Basically. What do all these things have in common? They're all basically light. Electromagnetic waves are what they're called, and I'm just listing areas from the electromagnetic spectrum. In simpler terms, they're all the same thing at different frequencies. It's all just electromagnetic waves, sometimes called light, but you can only see visible light. Other types of electromagnetic waves interfere with the world differently, whereas visible light specifically interacts with our eyes. I don't think it should come as any surprise that the same thing can manifest itself in so many different ways. I mean, you probably learned in like 3rd grade or something like that everything's made up of matter. Maybe in 5th grade you learned that everything is made out of atoms. No matter how different things are, they're all made of atoms. Maybe in 8th grade or something you then learn that atom was made up of electrons and protons and neutrons, and then you learn the entire universe is all just electrons, protons, and neutrons. No matter how different it seems, everything is made out of these. And maybe you even dug deeper, learned about quarks and leptons, and wait a minute, it was getting simpler, now it's getting more complicated. Aren't there supposed to be simpler building blocks as we get further? So enters string theory. String theory is the idea that all of these types of particles, no matter how different they seem, are actually all made of the same thing. And basically what that is little strings that are vibrating differently at different frequencies with different patterns. Just like how electromagnetic waves can manifest themselves in lots of different ways just by vibrating differently. The idea is that these strings vibrate differently to form different particles and interactions. So here are the pros of string theory. It unifies everything. It puts everything into one simple theory that explains everything in the universe. Also, if you know the math, which I don't, but this is what I've heard, it makes the math work out really nice and very pretty. Here are the cons. In order to find solid evidence of something, what you basically have to do is say, if X were true, we would be able to observe Y. Well, if string theory were true, we have no idea what that would imply about anything else, so we don't have a good way of just running an experiment and testing, is string theory true? Because of that, we have virtually no concrete evidence that string theory is true. Right now, it's just a really helpful way of modeling what we see going on. As far as I have noticed, there seem to be 2 types of serious physicists. One of them is the type that really strongly believes in the promise of string theory and that is the direction we need to go in. That is the unifying theory, and it is definitely accurate and what we need to pursue. Then there's the other type of serious physicist who thinks the whole thing is basically a joke and anybody studying it is wasting their time. I have not seen a lot of in between on this. Oh, you're asking what camp I fall in? No, I'm not a serious physicist. I'm a snarky physicist. I don't fall in either of these camps. I watch and laugh. And I learn about it because it's an interesting model, whether it turns out to be the best model or not. Next week, I'm going to go to one last crazy topic, and definitely a subject of debate amongst physicists and scientists and everybody else, and that is entanglement. Everybody wants to hear about entanglement. This is really weird, cool stuff, like it hasn't been weird and cool already. Anyway, that's next week's topic. Subscribe to this channel if you want to see it. Yes, there will be other videos between now and then.